Good evening. Are you able to hear me?
Good evening, ma'am. Yes, ma'am.
1 second. Let me. Yes. Okay. Muthukrishnan, what do you want to ask that question from the quiz 2?
Yes, ma'am. Yes. And some from GA.
Okay. Have you logged in from two devices, Muthukrishnan?
Uh, yes, ma'am. Yeah. One. Yes, ma'am. One from mobile, one from laptop.
Let me open the quiz 2 question. Okay. So, phi sin omega t, steady state voltage V1 and V2. V2, V1. Are you able to see the screen?
No, ma'am.
Now,
Yes, ma'am.
this was the question.
Um,
Here, what is your doubt?
no, ma'am. Actually, this is not this question, ma'am. The one which comes before, actually.
The one which comes?
Before, it's something like a half wave rectifier, but with the 3 volt voltage source.
3 volt voltage source. I don't understand.
Yes, ma'am. No, this is not the question, ma'am.
You
The
told yesterday
question
this was
is,
the question, right?
uh, no, ma'am. I might have,
Okay, then what is your
said
doubt?
wrongly. It is a half wave rectifier circuit, ma'am.
You're talking about which one? This one or some other question?
Some other question in the quiz too, ma'am.
Some other question in the quiz to half wave rectifier. What is that?
Uh, it, uh, we are required to find the output voltage at minus 5 volts.
Comprehension question.
No, ma'am, no. It comes before this question, ma'am, actually. Or shall I share my screen, ma'am?
Here, can you see right now?
Mm. Yes, ma'am, yeah. So, okay, then I think it comes after, ma'am, then. It is a different.
Which one?
Yes, ma'am, this question. Yeah, this one.
Okay.
So, how to find the answer for this question?
Consider the circuit shown symmetrical sine wave peak volt. If the diode is ideal 0 forward voltage drop, the output voltage V not across the. Yeah, is it? It's the circuit of a what? This represents the circuit of with this connection
Um,
of the diode. I mean, anode towards the top and like this.
yes, ma'am. So, till positive 3 volts, it won't conduct.
Okay.
And yeah, after that, it will start conduction. So, above 3 volts, we shouldn't see any output voltage, right?
Correct. This is
Um,
first of all clipping circuit. What will be the? I mean, is it a positive clipper or a negative clipper?
uh, mm, I think positive clipper only.
Positive clipper. Okay, positive clipper which clips at
Uh, yeah,
it clips
up
at
to 3 volts.
it clips at plus 3 volt. Okay.
Yes, ma'am.
We are asked to calculate the output corresponding to V in minus 5 volt.
Yes, sir.
Help.
Yes, ma'am. So when we give minus 5 volts,
Okay.
um, wouldn't it be minus 5 plus 3, the VO? Or
What happens during a negative half cycle? V in equal minus 5 is corresponding to negative half cycle, right? So negative half cycle means it will be like this. So you should what is Question. Gain is peak value 10. Okay. So this will be your expected output, right? Diode is what is mentioned? Ideal diode, right?
Yes, ma'am.
Or a forward voltage drop is given? No. Okay.
No, ma'am, nothing is ideal.
This will be your expected output, correct? Which will be 3. Negative half cycle. So you will get exactly the input. So what is B in that you should get at the output? I mean your transfer characteristics will be like this. This will be the output.
So in negative region, both x and y will be of the same value, is it, ma'am? I
Yes.
mean,
Output follows the input.
okay.
This portion
Okay.
that represents this portion, the transfer parameter.
Mm.
And again, why I thought it was this question because this was one question just like the comprehension question on Laplace transform where very few of you have attended. At least for V1, okay, but for V2, many of you have not done. So this is actually the circuit of,
Double voltage doubler.
yes, voltage doubler. So for this phi sin omega t input, what will be the steady state voltage for this V1 and V2? During positive half cycle, what
V1,
happens? You will have, what
yeah,
are the
V1
statistical
5.
diodes? D1 is forward biased and D2 is reverse biased. So D1 will be acting as short circuit. So this from this input, this capacitor C1 will be getting charged. So it will charge to the peak value
5
of the
volts.
input. So it will be Vm here. Then during
Yes,
negative
ma'am.
half cycle, this will become D1 will become reverse bias, so it acts as open circuit, and D2 will be forward bias, so it will act as short circuit. So during negative half cycle, what happens is uh, this will be the path for this. I mean, capacitor C2 charges in this way, so the polarity becomes like this. Okay. So already here you have Vm. So if you apply KVL here, what happens? You will have this V in minus this V2, this is which is voltage across C2, plus this V1 equal to 0. So here you will get it as this V2 as 2 Vm. I mean this will charge 2 Vm. So with this polarity, positive at the bottom, negative at the top. So with this given, it will be minus 10. V2 will be minus 10. V1 will be this peak value which is 5. So V1 is 5 and V2 is minus 10 is the answer. Many of you have not attended this question also.
Ma'am, in this case, will the C1 acts as a conductor?
C1?
Acts as a conductor.
Yes.
Okay, because the polarities matches.
Okay. What is?
Ma'am, in this Clipper circuit, which you just explained, V naught is the voltage across resistance R, right?
V naught is it's shown, right?
Diode,
Yeah.
diode actually.
V naught is across
The
together with
as per the
diode and this 3
question,
volt.
yes.
Sorry, I didn't get that.
I mean, I will show you here. This is V naught.
Across diode, you mean to say?
Not across diode. Across
Okay,
all together.
diode and the 3
And the
volt
source. 3 volt
voltage
source.
source.
Ma'am, ma'am.
Yes.
So if the input goes above 3 volts,
Okay.
the diode will be forward biased, and so it starts conducting, right?
If the input goes above 3 volts, uh, yes,
So all those time the output is 3 volts. Is it, ma'am?
correct.
Okay.
When the diode is not in forward bias, that is in reverse bias,
Reverse biased. So
there
it
will
will
be
act as
some
open
open
circuit.
circuit. Then how can we find the voltage? It's like, so in that point of
Yeah.
time we are neglecting the 3 volt source.
Yeah, yes, I think.
Is it
Is
clear?
that so? No, no, no. When the diode, I mean the voltage across, I mean the input voltage is less than 3 volts, and that means that the circuit is open circuit. In that time we are neglecting the 3 volts. Why are we neglecting?
3 volts won't play any role in that case because the terminal of that voltage source is not connected.
Yeah, yeah.
I think during reverse bias, since the diode will open and it is open circuited, so total input voltage will be appear in the output. It will follow output will follow the input voltage, and when diode is forward biased, the output voltage will be fixed at 3 volt. Am I right, ma'am?
Yes. When it is forward biased, that is this portion. It will get clipped at 3 volt, and the other way out, output will follow the input, because you can see here with this connection.
Another question that Muthu asked was the slope of this VTC, voltage transfer characteristics. Wouldn't the resistance impact the slope? Seems like it is means slope is 1 as you have shown, or will it means the R will impact the slope of VTC?
Uh, you are telling for negative half cycle, right?
Yes,
Portion,
means when
this
the
portion.
yes, when the diode is reverse bias, the slope shouldn't be minus or shouldn't be 1, I think, because there will be some voltage drop across R.
Yeah, but R
The
is not
reverse.
completely.
There is no current flowing through R, right?
Yes.
Yeah, got it, ma'am. Yeah, you're correct.
So, ma'am, the 3 volts is just it's crucial to decide at which point the clipping happens, right?
Correct.
Yes, ma'am. Yes, understand.
Suppose what if some forward voltage drop for this is being given, that will also come into picture here. I mean, if the diode
Yes,
is not ideal.
yes, ma'am. Yes.
Yeah, then
Then simply we
0.7
can
volt will
increase
get
the
added.
voltage of.
Yes.
In case we reverse the polarity of 3 volt voltage source, what will be the level at which the clipping will happen?
If we
Minus
reverse
3.
the,
Polarity of 3-volt voltage source.
you mean to say like this? Polarity of the diode or the source?
3-volt voltage source.
Like this?
Yes.
Okay, here what happens?
Here -3 should be the voltage level at which clipping happens.
So cathode is at -3, and for V in greater than -3, it becomes forward biased, correct?
Yes.
So for V in greater than -3, it becomes forward biased, and hence the V out will be flipped at -3 volts when V in is above -3. Till that, this will be open circuit, and you will get output follows the input when it is reverse biased.
Okay.
Then you were mentioning some from the graded assignment 11 or 12, right?
Ma'am, how
Yes,
will be
ma'am.
the curve, ma'am? VT curve, ma'am, for this second case?
What you have first, the mathematical expression will be for V in greater than -3 means how the waveform will be like this. Say here I take that -3. So it will be this is the portion, right? So it will be at -3 volts. So transfer characteristics will be like this. It will be how much? -3. So I should take it like this. Then what about that question? I mean, knowing one parameters in the two-port network, finding the other using matrix inverse or the other way out. Did you try it out?
No, ma'am, not yet. But I think inversion of matrix is easier.
I'll just show you. I will just give you the idea. You can just do it in this way. I think that will be easier.
Okay.
set parameters what you have. V1 is Z11 I1 plus Z12 I2. V2 is Z21 I1 plus Z22 I2. And you have Y parameters as I1 equal to Y11 V1 plus Y12 V2. I2 as Y21 V1 plus Y22 V2. So it will be like I1 I2 equal to matrix form Y11 Y12 Y21 Y22 into V1 V2. So this delta Y will be here Y11 Y22 minus Y21 into Y12. So from this here V1 will be, if I replace the first column by this I1 I2 and then Y12 Y22 by delta Y. So V1 equal to I1 into Y22 by delta Y minus Y12 into I2 by delta Y.
Please pull up. V1, please explain them. V1 value.
We have by Y parameters like this. That is I1 is Y11 V1 plus Y12 V2, I2 is Y21 V1 plus Y22 V2. So from this, these two equations, you can write in matrix this V1 as what? In this matrix, you replace the first column by this I1 I2. Then the second column as such, then by this delta Y, where this delta Y is this one. Y11 into Y22 minus Y12 into Y21. Similarly, I can write V2 as Y11 Y21. Here I will replace the second column. So that will be Y11 to I2 by delta Y minus I1 by Y21. I11, sorry, minus yes, I1 by Y2. Y21 by delta Y. So comparing these two equations, here V1, V2 we got that already. The expressions for V1, V2 we have for the set parameters. So comparing the two expressions for V1, we will have Z11 equal to Y11 by delta Y, Z12 equal to minus Y12 by delta Y, Z21 equal to minus Y21 by delta Y. Correct. Compare this expression for V1 with this one. I mean here. So you will have the coefficient of I1 here Y22 by delta Y. So here that is Z11. So Z11 will be y22 actually here. Correct? Y22 by delta y. Similarly, here what you have, I2 coefficient is minus y12 by delta y. So comparing this, you will get, so this is actually set parameters in terms of y parameters. Similarly, in this way, you can find the other way also.
Ma'am, please explain the matrix format for V1.
I have just written both the equations. Okay, set parameters, these two you know, correct? Expressions for V1 and V2 that you get out of the set parameters. V1 is Z11 I1 plus Z12 I2. V2 is Z21 I1 plus Z22 I2. Similarly, Y parameters we know, we will be getting the expressions for I1 and I2. So that will be Y11 V1 plus Y12 V2, Y21 V1 plus Y22 V2. So these equations we already know. Now in the matrix form, I have written this Y parameters as I1, I2 equal to Y11, Y12, Y21, Y22, the Y matrix, the Y parameter matrix, then into V1, V2. Now the delta of this matrix will be Y11 into Y22 minus Y12 into Y21. Then these are all just the matrix concepts, nothing in relation with the circuits. So V1 will be now in this matrix I will be replacing what, the first column by this I1 I2. So I1 I2 I have replaced, the second column I have retained as such divided by this delta y. Similarly V2 will be, I'll be retaining the first column as such, second column I will be replacing by I1 I2 divided by delta y. So accordingly I will get this as V1 equal to I1 into Y22 by delta y minus I12 into I2 by delta y. Similarly here it will be Y11 into I2 by delta y minus I1 into Y21 by delta y. So these are the expressions for V1 and V2 from the y parameters. You have the expressions for V1 and V2 from the set parameters. So comparing the expressions, two expressions for V1, you can find out the relation. Similarly, comparing the expressions for V2, I1 into Y21 delta y. Now you compare these two. Say these are equations 3 and 4. These are equations 1 and 2. So 1 and 3 are expressions for V1, 2 and 4 are expressions for V2. Comparing, you will get the relations. This should be Y22. Okay. Set 2 to what do you get? It is the coefficient of this I2. Y11 by delta y. Is it okay?
Okay, ma'am.
This same method you can apply the other way out also, which is given and which you need to find out. I think this will not consume much time.
Yes, ma'am.
Yes. Now the questions from the graded assignment 11 or 12. So that
Yes,
we
ma'am.
can.
12th one, third question, ma'am.
What was that question?
Yeah, it is to find, I think,
It is to find.
the transfer function.
Transfer equation.
Wait 1 second. Let me go to the portal then. Did you go through the actually solutions for the graded? I mean the PDF page. Then
For
also you
this
have
question, I
doubt.
think yes, ma'am. For this question, I think the answer isn't fully given, ma'am. Only the process is given, I believe. Actually, I think when I derived, I got one extra zero in the option one, ma'am. That is 2 crores in place of 20 lakhs.
Wait, I will just check. Are you able to see the screen?
Yes, ma'am.
You're writing the, I mean, seeing the window or the screen? I mean, the writing device alone or graded
No, ma'am.
assignment?
The page which we left last, that is the
Right
Z11
now,
is
are you
equal to
able
Y.
to see the third question in the graded assignment right now?
No, ma'am.
Okay. Are you able to see the question?
Yes, ma'am.
Here you will get that k value 100, correct? And then you take the other, I mean, constant terms from this 5, all those things, you will get this value. What is the doubt there?
So here the K value is 100, isn't it, ma'am?
Yes, k
It's
value is
not
100.
1,000.
I mean, when the constant value, when it is written in the standard form,
Oh,
that you will get
okay.
it as 100. Then when you make it of this form S plus, standard form is 1 plus in that form. Am I right? So when you make it in this form and you find change the constant value, you will get this value.
Yes, ma'am. Then fine.
In
Yeah.
the standard form, you get that constant value or whatever A or K, that value, you will get it as 100. You can just cross check.
Oh. Yes, ma'am. Okay.
Because 20 log that K is this 40 dB. So you will get anti-log 2, correct?
Yeah, ma'am. Yeah.
So you will get it as 100.
Yeah, yes, ma'am. Yes.
Okay.
I
Then one from graded assignment 11.
No, ma'am, no. Then the mark question.
Mock end semester.
Yes, ma'am.
Mock end semester after Wednesday, because right now it is in a graded assignment mode. Na? So those who
Yes, ma'am.
haven't attempted it as exam on the other day,
Yes,
it's just an time given for them also to do that, after which we can, maybe on Thursday we can do.
yes, ma'am. So, ma'am, can you just give some hint, ma'am? Because
Which question? I mean,
the
the
same
same body
kind of
part
question.
question.
Yeah, yes, ma'am. But no values are given.
Yeah, that is
But
fine.
we are
From the just another question where from the body plot, how first you find out the transfer function, then from that expression of the transfer function, you can figure out the corner frequencies. Correct?
yes, ma'am. So just by having the graph, is it possible to calculate, ma'am? Then
Yes. First, you find the transfer function, just like how many zeros, poles, etc. with the that slope, then change in slope where it happens, etc. So first, you find out the expression for the transfer function. Then once the transfer function is also known, you or even from the graph where the change in slope happens, you will get the corner frequency. Correct?
No, but the thing is, none of the
But it
intercepts
is
are given.
yeah, corner frequency is given to be omega 1 and omega 2, which need to be found out. So first you
yes, ma'am.
find the transfer function, from which you can find out the corner frequency.
No, the thing is, at least we have to know the intercepts with the axis.
Let me just check. I don't
Some,
remember that question. I mean, exact values, markings
13th
shown.
question.
I will just check. Anyway, you will
because
be.
only the graph is given. That's why.
Are you able to see the screen?
Yes, ma'am.
Hmm. I think those are not needed. It's fine. You just try it out. I'll discuss on
Yes, ma'am.
Thursday. With the from the transfer function, you can find out. That is fine. Even markings are fine.
Okay. So the intercepts are not needed, ma'am.
I hope. Yes.
Yes, ma'am. Because then I mean then how to find the k value, ma'am?
You are not asked any k value, right? K value is not needed for finding the corner frequency, correct? K
No,
value
ma'am.
decides
For
only whether it is
finding,
shifted upwards or downwards.
yes, ma'am.
But you went to find
Same
omega
corner
1 or
frequency will be when you even when you have a change in k.
Yeah, yes, ma'am. Correct. Yes, ma'am. Yes.
K value is not required for finding the corner frequency. It will not affect. Only
So
that decides whether
we should
if the
be
same shape curve will shift upwards or downwards, depending upon whether k is increased or decreased, whatever, relatively.
Yeah, this
ma'am.
question, hello.
Correct?
Yeah, this question, how to do it, omega 1? Can you again repeat?
No, no. He was asking whether k we don't know k value. I mean that constant term in the transfer function. Without knowing that, how to find out this omega 1 and omega 2? But that is
Yeah.
not required. Correct? K value will not be affecting the value of this corner
uh,
frequency.
no, k is not required, but we need to have at least one of the intercepts
Yeah,
Yes,
H
ma'am.
dB is
Because
required now, y axis.
where it is
if
cutting the
we
y-axis
This
yes, ma'am.
one.
Because if we shift to this
downward.
graph to left or right, um, then it should make difference, no, ma'am. But
Yes, ma'am. Whatever you are saying, the corresponding value of y-axis when omega 1,
yeah,
we need to at least have that, or at least the point where it is intersecting with x-axis or at y-axis. Any of those is
then we can't have difference if this shift graph is shifted left or right. No, ma'am. Only the intercept can make a difference here, I think.
Yeah, I think y-axis value for omega 1 and omega 2 is required here.
Or at least
Because
the point at which the graph crosses 0 dB, maybe.
and this 40 dB is what? It is a quadratic equation.
Which one 40 dB? Here it is given only for the slope.
what's this?
Yeah, so 40 dB slope means it will be 0, correct? S1 plus some
Correct.
0,
Correct.
sorry, yeah, 2 0. Otherwise, quadratic.
Correct.
So, what is this one actually? I mean, how to fix this then without intercept?
I'll just check it out. I told you now. After minus, let me just check it out. I will tell you
Yeah.
after
Yes, ma'am. Yes,
this
sure.
deadline is over. I will just surely we will come back to this question. No problem.
Yes, ma'am. Yes.
So shall we move on to the today's discussion then?
Yes, ma'am. Yes. That's all.
Try out this question.
And your screen is not visible, ma'am. Only enter knob is showing.
Now? Is
Yes,
it
ma'am.
Yes, ma'am.
okay?
Yes, ma'am.
Ma'am, is it one?
What is the value of I?
Ma'am, what the question,
One.
ma'am? Find the value of I if the diode is ideal with
0 forward voltage drop.
1 amps.
1 amps.
Is it 1 amps?
1 milliamps.
Yes, 1 milliamps. So how do you get? How do you check for the status of the diode?
ma'am at anode, ma'am. Voltage device circuit is given, ma'am. So
Okay.
the voltage at the anode of the diode will be
6.
6 volt,
Correct.
and at cathode it will be 3 volt. So diode is forward biased, and difference in voltage is 3 volt, and the resistance is 3 kilo ohms, ma'am. According
So
to
it
that, we will
has I
find the
1
value.
milliampere. So clear, correct? So actually you will get it as I is 6 minus 3 by 3 kilo. Voltage at anode will be 12 into 6 by 6 plus 6. A diode forward voltage drop 0.7 volt. Find V0 and I.
And what is the value of voltage across the 3 anode, ma'am?
3.
Both are 3 volt, na, ma'am?
Yeah, both are 3 volt. One second. What is the value?
V out will be 2.3 volt, ma'am,
Yeah,
and I will be 1 milliampere, ma'am.
correct. 1 second. Sorry. Yes, what will be the status of diodes D1, D2 and D3?
What?
D1 and D2. What are the status of diodes D1, D2 and D3?
D1, D3 reverse biased.
I'm not able to hear you.
D1, D2 they are reverse biased and only D3 is forward biased. I mean not
Okay.
reverse biased but they are not active.
How do you say D1 and D2 are reverse biased?
Because together the voltage drop must be at least 1.4 to get them into forward biased.
Okay.
Since D3 will be getting forward biased first,
Think forward bias.
there's no chance. There's no chance for D1 and D2 to be forward biased.
If D1 and D2 are forward biased, together it will be 1.4. After that, what did you tell?
Afterwards, anyhow, as D3 is forward biased at any cost, if even D1, D2 are forward biased or reverse biased, D3 will be forward biased.
Why
So once
D3 is
again,
anyway forward biased?
because the forward voltage drop is very less when compared to D1 and D2 together.
Okay, so here D1 and D2 are reverse biased, and with D3 forward bias, this V0 will be 2.3 volts, which will give you I as 1 milliamps.
Ma'am. Ma'am.
Ma'am,
Yes.
in the above question, if in the upper branch, if one of the diodes is ideal,
Okay.
what will happen?
One of the diodes is ideal means with zero point 0.7 what you get. You have to actually check for you. I mean, proceed with one assumption. Say both of them are forward bias D1 and D2. Then you just see, and also say take D3 is forward bias. You check for calculate the currents. You will have something and check whether that your assumption is valid. Say for example, if you get with that assumption something like this, the current is flowing in this direction, then that will not happen because with this diodes connected in this fashion the current direction will be rightwards, correct? So something you
Yes, ma'am.
start with some assumption, and then you find out the voltages and currents, check whether your assumption is valid or not. With that only we can tell. Okay.
Yes, ma'am. So if one of the diodes is ideal, can't we just proceed with that? Even D1 and D2 will also conduct at that time, because the voltage drop at that whole branch is just 0.7 volts. So VO is sufficient to make it forward bias.
What happens if one of them is reverse biased?
Mm, yeah, but
You
so
will not
is it
get pass
possible,
through the
ma'am, to
current, correct?
have? Yes, ma'am. So, but is it possible, ma'am, for having one diode reverse biased if in the case when one of the diodes is ideal? Uh,
Yes, that can happen, right? It depends upon
I
this
mean,
voltage here, correct?
until we keep both the voltage as 3 volts.
Yes,
Okay.
correct.
Yes, ma'am. But but having ideal diode,
You told one
isn't
of
it
them is
just?
ideal, right?
Yeah, yes, ma'am. Yes.
Uh,
So, won't it make the upper branch also very much similar to the lower branch?
when one of them is ideal, or you say both?
Yes, ma'am. No, no, one of them is ideal.
One of them is ideal. Zero.
So, because anyhow, we will have only 0.7 voltage drop across the whole thing, right?
Correct. That will not make difference.
Yes, ma'am. So, by changing only one diode to ideal in the upper branch, all three diodes will conduct. Is it?
Correct.
Yes, ma'am.
So 6 volt, 2 kilo ohm, D1, D2. It's also, this is actually 1 kilo ohm. Okay. This is 1 kilo ohm. You have to find out V01 and V02.
Are these diodes ideal?
Yes.
Is VO1 and VO2 same?
Yes. How much?
2 months.
2. No. D1 and D2 both are connected
4
in the
months.
same fashion, right?
Yeah. Uh, 4 months.
No. What will be the status of the diodes?
VO1 will be -2.
Which one?
VO1 and VO2 both will be -2.
-2. No. No. Just check once again.
There will be 0, huh? Since both of them are ideal.
Yes. Both of them are ideal.
0.
Answer is?
0.
Yes. So D1 and D2 will be?
Both of them are forward biased.
Yes, both are forward biased, and that will give you V01 equal to V02 equal to 0.
Yes, ma'am.
Ma'am, please explain, ma'am, once again.
All of these questions we have to go through assumptions. First we'll assume
Which one?
it's correct. All of these questions we'll go through assumptions. First we'll assume something. If it's we'll check.
Yes, yes, that is the way to do. As I told you, you go with some assumption, then you check whether your assumption is right by some means. That is one thing I pointed out to the with the previous question, just like that. Something, if you go with one assumption, say for example, you are getting the current to be in the reverse direction. The current cannot flow from cathode to anode; it will flow from only in this direction. That is the diode symbol, basically, correct? So something like that, you check for the validity of your assumption. That is the way out. You can't tell otherwise what will be the status of the diodes.
Ma'am?
Yes.
Ma'am, I do think VO1 and VO2 will be equal to -2.
No. Wow. What did you get for the status of the diodes?
Yes, ma'am. I think D1 will be in off condition.
Okay.
Because if we just see the left branch, that is D1, then 0 will be there, right? Above 1 kilo ohm.
How?
Yes, ma'am. Because D1 positive side is connected to ground.
Okay.
So if we assume D1 is conducting,
Okay.
I mean just D1 is conducting, then we will have
Here you have
0 volt.
minus 6 volt. Here you have
Yes, ma'am.
minus 6 volt. It is not ground.
Yeah. No, ma'am. I'm saying the anode of D1.
Yeah, that I understood. I mean, you are coming to say that since the anode is 0 volt, you tell that this also something like that. You for that I am telling it can be. I mean, this cathode of D1 can be at a negative voltage, right?
Yes, ma'am. So
That
it will start conducting. That is D1 will start conducting, and after that, the voltage at V0 V02 will become 0, right?
okay, correct.
Likewise, if we leave the D1 aside and just focus on D2,
Okay,
then the voltage will be, I think, -2 maybe.
how can you keep it aside if you have 0 volts here? What will be the status of D2? That
Yeah,
will
yeah,
also
yes,
be
ma'am.
forward bias, right?
Yes, ma'am. Yeah, yeah, yes, ma'am, correct. Yes, ma'am. So both the diodes will conduct, right?
Correct. So that will
Yes,
give
ma'am.
you
Okay.
V01, V02 as 0.
Okay, ma'am. Yes.
So go generally for this diode question, you just go with some assumption and then you decide ultimately what is
Yes,
there.
ma'am.
So few more questions you just can try out. Here also diodes are ideal. You need to find out.
Ma'am,
Yes.
in the last question,
Okay.
is it safe to say no current will flow through D1?
No current will flow through D1. Yes.
Yes, and then we can say that D1 is inactive, right?
No, we got it. V0 to be 0. How did you get it actually? With V0 to 0 and the other anode voltage also 0, then only you are telling that the current flowing is 0. How did you get
Yes,
V0 to
ma'am.
be 0?
Yes, ma'am. The V01 and V02 is 0, right? No?
Correct. I mean, how did you arrive at conclude that V0 to be 0 with considering D2 also?
Yes, ma'am. Because if we take D2, it will cause -2 at that node. So
Correct.
comparing to that, 0 is higher. So we usually we should take the higher magnitude. So it's safe to assume the V01 and V02 is in 0 volts.
Correct. Now, with that, how do you say that to keep it say D1? I don't understand what is your point.
No, ma'am. So then D1, I mean, no current should flow through D1, right, ma'am? Because both the anode and cathode
Are at the same potential.
voltages are same.
Ah,
Yes, ma'am. So even though D1 is forward biased, no current will flow through it, right?
correct.
Yes, ma'am. Yes, ma'am. Likewise, if anode and cathode voltages are same, should we say it is forward biased or equal biased? Or
That is the
how?
point. Just we say that it. I mean, it is forward biased. The starting point. Then it starts conducting when the anode voltage becomes greater.
Yes,
I mean, the
ma'am.
current starts flowing.
Yes, ma'am.
We just
Yeah,
say when
that's
the point it gets forward biased when both of them are equal. And this
okay,
is the
ma'am.
way out we have even for the clipping circuits and all that VA voltage taken in the lecture. Do you remember?
Yes, ma'am.
And that is a critical point.
Clicking. Yes, ma'am. Yeah. Yes, ma'am. Yes.
Now in this question, again the diodes being ideal, find the value of V01 and V02.
Ma'am, in the previous question, can we assume it V02 equal to minus 2 volt, ma'am? Because
equal to minus 2 volts. Okay.
because voltage divider circuit, ma'am, and diode D1 will be forward biased since anode voltage 0 volt and cathode voltage of D1 is minus 2 volt. It is forward biased, ma'am. Okay.
Okay.
And V01 also minus 2 volt.
We will not assume for V02 is minus 2 volts. We can't assume something like that, correct?
Means out of ma'am
We
out
will
of 0
assume.
volt
Uh,
out of 0 volt
Okay.
as for the discussion, and according to my discussion minus 2 volt, 0 volt will be greater, that so that your previous discussion will be allowed, na, ma'am?
Correct. I mean, I mean
Okay,
to say you go with the assumption that both are forward biased or some assumption you start with. Then you proceed finding the values for this current or voltage. And then you check the validity of your assumption. That is the way how to do with the diode circuits. But you can't assume something like that V02 is minus 2 volts.
because I have according to voltage divider circuit I have got the value, ma'am.
That goes with the assumption that both of them are forward biased, correct? Only if D2 is forward biased, you can consider it to be a voltage divider. Correct?
What, ma'am?
Only if you assume D2 is forward biased, it becomes a voltage divider.
Ma'am, but still the both voltages are same, right?
Voltages will be divided, ma'am. Voltage difference will be divided, ma'am.
Correct. This circuit will act as a voltage divider only when D2 is forward biased. Am I right?
Yes,
Yes, ma'am.
And when that happens with D2, with that you check the status of D1. That is the way how to do. You are telling, I mean, you will be saying it in some other words. I mean, I say with reference to the diodes, you are telling with reference to the node voltage.
Yes, ma'am.
Okay. But then did you then conclude, I mean,
According to this voltages also, both the diodes will be forward biased, ma'am.
no, then you will get different value for V01. Am I right?
No, ma'am.
You told V02 to be minus 2 volt. Okay, fine. That is by voltage divider. Then how did you proceed?
Ma'am, D2 because D2 forward voltage is 0, ma'am. So V01 will automatically same voltage, na, ma'am. According to same voltage as V02, na, ma'am. But as for the previous example, we always consider the maximum value of the cathode voltage. So according to that 0 voltage we have chosen, ma'am.
Minus 2 also. Okay, minus 2. D1 is forward biased. What about D2? D2.
No, ma'am. 6 volt and minus 6 volt is there. So
Okay.
difference of voltage will be 6 minus or minus 6. That means
Correct.
12 volt, ma'am.
Correct.
So total resistance in that path will be 3 kilo ohms, ma'am.
Correct.
So the voltage across 1 kilo ohm will be 4 volt, and across 2 kilo ohm will be 8 volt, ma'am. So total 12 volt is coming, ma'am, in this path.
Okay.
So here the voltage of V2 according to that will be -6 plus 4 volt, ma'am, because voltage across 1 ohm will be 4 volt. So -6 plus 4 will be -2 volt V02. And for a diode D1, anode voltage is 0 volt and cathode voltage is -2 volt. That is voltage of V02. So it is also forward biased. Remember, D1 is forward biased, and since D2 is ideal diode, so V01 will be also -2 volt. But which path we should consider? 6 volt and -6 volt, or 6 volt and 0 volt, that is ground? Which path we should consider first, ma'am?
Wait, I'm checking. For V01 to, if it is -2 volts, what will happen? -2 here, -2. So no current. Okay. But you will with -2 you will not get forward biased for D1. How did you get it? Because
-0 volt anode voltage.
if you assume D1 to be forward biased, then directly you will get V0 to be 0 only. So that -2 will be invalid, correct? You were telling that even for V01 and V02 to be -2 volt also, then this then also the status of the two diodes are forward biased. That is your point, correct?
Yes.
And that will not happen. Why? Because if V02, if diode D1 is forward biased, how do you get V02 to be -2? It will be become
Yeah.
0. Diode is ideal, it is mentioned also when it is forward biased, because of this anode voltage which is grounded, V02 will anyway become 0. So when V02, as you say, as per your assumption, -2 volt, how do you say D1 is forward biased?
Ma'am, 0 will be the final answer. Thank you, ma'am.
That will become 0 volt, correct? V02 if the diode D1 is forward biased, because of the anode voltage being grounded. Because it acts as a short circuit closed switch, correct? Directly that this ground will affect here.
Yes, ma'am.
Correct?
Yes, ma'am. That means if ground and supply voltage are joined together, it will always ground voltage will appear. Yes, ma'am.
So your assumption is wrong.
No. After forward bias, it will be grounded, na? That means if my
I mean to say, you were telling that if you assume like V02 is -2 volts and V01 is also -2 volts, then also both of the diodes are forward biased. That statement is wrong, I am telling. Correct? That was your statement. Am I right? You were telling even for V01 equal to V02 equal to -2 volt, both the diodes are forward biased. Correct?
Yes, ma'am. As for the conclusion, ma'am, it is, I think, right, ma'am. Because since as V02 equal to -2 volt, then immediately D1 will be on, turn on, means short circuited. After that, ma'am, the ground voltage will appear at V02, ma'am.
Correct.
Step by step process. So ultimate the final answer will be 0 volt.
Zero.
Final answer will be
Correct.
accurate. Yes, ma'am. Thank you. But will intermediate state will be minus 2 volt, no, ma'am. Minus 2
Ye-
volt. After that, forward voltage will final 0 volt.
Yes.
Yes, ma'am. Thank you, ma'am.
Now for this current question.
VO1 is 6 volts. No?
VO1 is 6 volts. Correct.
VO2 minus 6 volts.
Correct.
So both diodes are reverse biased.
Reverse biased.
Please once again explain, ma'am, this question.
This also.
Also, I think in the same way, ma'am.
Arithmetic.
I think previous
Yes.
concept, ma'am.
Yes.
Initially, ma'am, may I tell, ma'am,
Which one?
this question, ma'am, current question.
Yes, current question. Again, you go with the same thing. You assume the status of the diodes, find it out. You will have what both of them in reverse biased condition, so that V naught one will be 6 volts. V naught two will be this minus 6 volts. Three more questions on diodes, and then we can move on to the transistor.
Four volts and 1.2 million.
Yeah, welcome. 3 questions.
Yes, 4 volts as Subhash said.
You can consider here if it has a forward voltage drop of 0.7 volts. Here you may consider, okay, whatever, maybe a diode idea.
Four volts.
Yes, in the first
1.3
case,
milliamps.
V will be,
4 volts.
what will be the status of the diodes? D1 and D2 will
D2
be
or reverse bias.
reverse biased in this order. If we take D1, D2, D3, D1 and D2 will be reverse biased. D3 will be forward
D3
biased, so that will
forward
give you 4 volts. I will be, you can find out. Okay, then
1.3 milliamps.
here, if it has a forward voltage drop of 0.7 volts,
2.3 volts.
here what will be the status of the diodes? All of them will be forward biased, so it will be 2.3 volts.
2.3 milliamps.
Yes. Then
6 volt. 3 milliamps.
okay, maybe if
D3
you
reverse bias.
correct.
What is the logic, ma'am? The arm with the maximum voltage at cathode will be will that will be selected, is it?
Correct. So here D1 and D2 forward biased, D3 reverse biased. Here what will be the status of the diodes for this?
All are forward bias.
All are forward biased. Here D1 and D2
D3 reverse bias.
okay, so maybe a few more
Ma'am?
yeah,
Can you scroll up a bit, please?
yes,
Yeah, in this 2, 3, 4 ladder,
okay,
this question, if instead of grounding this resistance, we have a 5 volt battery connected there with positive on the upward side,
okay,
then none of the diodes will be in the forward bias case, is it right?
correct. Yes, that becomes all of them are reverse biased.
Okay. And in that case, the value of resistance doesn't matter.
Yes, doesn't matter. Only that will determine only the current. Correct. Here it current will be 0.
Yeah, means that only comes in picture when there is a complete path for current to flow. If all the diodes are reverse biased, then it doesn't matter.
Yes.
Okay. Okay.
Shall we move on? Fine.
Yes, please. Thank you.
Okay. So few more questions on diodes. I will be anyway giving you, as I told you, the questions being added to yesterday's session also. So separate PDF I will release for the 3 revision sessions. So there you can see additional numericals that you can refer. Anything else, and thereafter, if you want to clarify, you just put it in the discourse. I mean after Thursday, because we will be winding up with the Thursday session. So just go through the revision PDFs also once it is released. So here, one another thing that I wanted to discuss was that, let me just take it, that 1 second. Maybe I can take the capital letters. So just wanted to discuss on this Darlington pair. So Darlington pair is otherwise called as, do you remember? I think it's mentioned in the week 9 lecture, problem solving. Do you
And
remember?
emitter follower is different, man.
Correct, emitter follower.
Man, same name.
Ah,
Okay.
so tell me, what do you know about this Darlington pair? Why, I mean, where can it be used? Why it
Here
is called as the super transistor?
the beta will be multiplied. The whole overall beta will be large.
Correct. So actually, it's just like if you see this as a, these two as a composite, this one structure. So altogether, if you consider it to be a single transistor with the 3 terminals coming out, collector, base, and emitter. So this one transistor is actually comprising of these two transistors Q1 and Q2. So here you can see, say for example, if you have this Q1 with beta 1 and Q2 as beta 2 with beta 2, then you will have the multiplication effect of those two gains. Okay, so this finds application where you require a high value of gain. Also, to make completely, I mean, nullify the not we can't say nullify, but anyway, almost making the base current to be zero compared to the other cases. Correct? Beta is being very large, so beta 1 and beta 2 it gets multiplied. So if both of them as beta, it will be beta square. And I think we had done one question on Darlington pair through the assignments. So here you have IB. Let me just show you.
Ma'am,
Yes.
ma'am, this emitter follower term, isn't it the another name for common collector amplifier?
Yes, common collector is referred as emitter follower.
Yes, ma'am. So, but this Darlington pair, it's different, right?
Because in common collector, in common emitter, the common thing that I mean, mostly we have seen the configuration. Mostly we have seen is the common emitter.
Yes, ma'am.
In that, can you just tell me where is the input taken? In which terminal input is being
Base,
applied to the
base
base? Output is from
collector.
collector, so that emitter is coming into common. Similarly, in that way, common collector will be input is
Base, I think.
base, output will be
Output emitter.
emitter. So here also the output will be taken from the emitter and input is to the base. So this will be referred as the emitter follower. If we, I mean, this configuration when employed in the amplifier.
Okay. So the Darlington pair, if we take the output at emitter side, then only it will be called as emitter follower.
Correct.
Is it?
Other than that, basically, it is for making still, I mean, less the base current, and also, as you mentioned, since the beta is getting multiplied to get a high gain.
Yes, ma'am.
Okay, so now
Here, Darlington pair always call emitter follower, na, ma'am?
yes, I will. Maybe we haven't seen the exactly in the amplifier configuration. We are just only seen, I think, with this beta multiplied. There you can see we will be taking the output from the emitter. So it is actually the emitter follower common collector configuration. Yes, we haven't
And
seen. I
also
think.
here,
Tell me.
also here two collectors are common here, na, ma'am?
Correct. That is called. That is what this altogether. It is just like a super transistor with beta, which is the product of these two. And if they are the same, it just will be beta square. So it's just like these two Q1 and these two transistors Q1 and Q2 forming this transistor, so that the terminals coming out are base, collector, and emitter. So you were telling about this connection, correct? Collector.
Yes, ma'am. Both are common.
Yes, yes.
That
So
means
that's why it is
always
because of this composite structure only, it is called as the super transistor. That is, um, if you consider this part, input is given to base. You will have this emitter. We take the output at the emitter. Why? Because this is fed as the input to the next transistor. Correct. So this is referred as the output emitter. Okay. So this output from the transistor Q1 is fed as the input to transistor Q2, and that gives you the large gain, high gain. So this altogether makes this one. So that is why it is called as a super transistor. So the output of Q1 is fed as the input to Q2. So emitter is the output terminal. That's why it is the common collector configuration or the emitter follower.
Yes, ma'am.
So now one question on Darlington pair. I think other basic things we had discussed. Maybe if you otherwise don't require for this week 1 to week 5, which is the Thursday session, maybe we can do it like as I told you. I will just give you the corresponding revision PDF for that week 1 to week 5. Maybe just as in today's session, anything to be clarified from those weeks you may ask. Other than that, I wish to spend some time, at least 1 hour, for this one. Altogether, at least to, some major topics where we need to focus, some things to be emphasized concept wise, that we can do on Thursday. Maybe numericals you can refer to the revision PDF once released. Is that fine for Thursday session? Because week 1 to week 5 comparatively, the weightage will be less, as you see in the mock paper. Of course, you have one comprehension you had in the mock paper. Yes, Venkat.
Ma'am, isn't today's session meant to be like yesterday's session? Like
Today's
you
session?
explaining the concepts. Like week 8, 9, 10. Won't you
Okay.
explain like week 11 and 12 what you have done yesterday?
Yeah, that's what.
Like
For
today,
that only I'm asking,
today.
because Thursday it is planned for week 1 to week 5. Correct? You would have seen in the calendar also.
Yes, ma'am.
So that's what I'm asking. If it is okay for you, week 1 to week 5, just like I can give it as the PDF, some numericals just for your additional tutorial, like additional practice, something like that. If you're okay with all those dependent sources or whatever you have seen there, then what else you have? That 4 and 5 is on Laplace. So if those things are okay for you, I'm talking in common for all of you. If it is fine for you, we can plan it like on Thursday's session. 1 to 5 can be just released as PDF. You can just refer through, and if you have doubts, you may put it in the discourse, and we can do that. So that Thursday's live session, we can discuss on this extended. This week 6 to 9, whatever concept-wise, the things that can be emphasized can be done. Is it okay?
Yes, ma'am. That would sound great.
Yes, ma'am.
At least for me.
Okay.
Yes, ma'am.
And further, if you have any doubts,
Ma'am, there was one
quiz to comprehension.
there was one comprehension question of quiz 2 on Laplace.
Yeah.
On Laplace.
Okay. The general things we can discuss. Other than that, once I plan to, at least by Thursday morning, before you come to the last live session, I plan to release this revision PDFs. So that will, I wish to add the questions in addition, other than that what we have discussed in the live session. Okay, so that you please refer. If you have any doubts, that you can ask through the discussion forum. So that live session we can use for concept revision, going through something like lecture topic revisions. Okay, so one question on Darlington
Okay,
pair
ma'am.
we can today, and we can wind up for today's session. Rest on Thursday. So one question on Darlington pair that you can write out. Let me just take that question. Yes. So this question. but I think this we had done through the assignment.
What is
Ma'am,
it?
is it
Get C?
Which one? VCE Q2. I mean VCE of Q2 is 5 volts. For that, what should be R1? Both have beta is 29 and VB is 0.7 volts. Is it done through the assignment? I think so.
I think so, ma'am. I can't recall it clearly, but there was something like that.
Correct. Yeah, it's okay. Anyway, we can go through once again. Can you just write out right now?
Yes, ma'am.
So VE Q2 will be 12 minus 5 volts. You will get it as 7 volts. So with that, IE2 will be 7 by 1.5 kilo ohm. Then this base voltage of VB1 will be
ma'am?
VBE1, 1 second. This VBE1 plus this VBE2. So that will be 0.7 plus 0.7 plus the voltage across the emitter. So that will be 8.4 volts. Yes, tell me.
No, ma'am, is it 20.25
Yeah, one
kilo?
second. I don't know. Let me check. We're doing it right now. So IE2 equal to beta 1 plus 1 into beta 2 plus 1 into IB1. So here both betas being the same. IB1 equal to IE2 divided by beta plus 1 the whole square. So 4.66 divided by how much is beta? 29. So 30 square. And IB1 will be 12 minus VB1 divided by R1, from which you can find out
Please
R1.
pull up, ma'am.
So this you will get it as some 5.18 microampere. So this implies R1 equal to you can just cross check your answers.
Yes, ma'am, 694.
So if time permits, at least for some major things, starting from week 1, we can mention the applications also before we end the course. Okay, I mean on Thursday session, where each one finds the application, something like that, we can do if time permits. So is it fine?
Ma'am?
Yes.
So, ma'am, at that place, should we use beta plus 1 whole square or beta square plus 1?
Beta plus 1 the whole square, correct? Because you will have that IE is equal to beta plus 1 IB, correct? IE
Yes,
equal
ma'am.
to beta plus 1 IB. So that will be
Yes, ma'am.
beta plus 1 the whole square.
Okay. Yes, ma'am.
Correct?
Yes, ma'am, I think. But the overall beta is beta square, right, ma'am?
That is fine for this question being the same. For this
Yes,
one,
ma'am.
it's mentioned that both of them are betas 29.
Yes, ma'am. Yes. Okay.
Okay.
Yes, ma'am.
Ma'am, please show the last portion, ma'am, of this answer. Ma'am, here, ma'am, after 5.18 microampere, next what, ma'am? Modulus of beta.
IB1 will be this 12 minus this VB1 divided by R1. Correct. This VCC minus this voltage at base divided by R1. That will be the current flowing through R1, which is IB1. So IB1 we have calculated, from which we can calculate R1. Correct? Hemant.
Yes. Yes.
Yes, Venkat, tell me.
If it's possible, can you conduct one more session on daytime? I mean, during
Section?
mornings. One more session during morning time. Anyhow, we are planning to give an PDF. So
No. What do you mean? You want the session during the morning time?
yeah, ma'am. Like other than the one we have on the Thursday.
I don't know
If it's
because
possible.
I will just let you know because we are having some work. So morning session, whether I can devote, I don't know. That I may not be. I am not sure. I will let you know. Why? What do you want to clarify actually?
No, ma'am, actually, you're telling that you will even cover few things like applications of all the weeks. So that thing you can plan on morning so that Thursday's whole session can be devoted to this.
Yeah. Anyway, I told you that application only if time permits. Other than that, if you want to know it anyway, I will just see. I will just tell you on Thursday. Okay.
Yes, ma'am.
Yeah.
I think just one more session won't be enough. Anyways,
One more session completely. I don't know. I will just check and let you know.
yes, ma'am. Please let us know.
If possible, or else we can plan it accordingly. Whichever is required as such during the live session, we can do. I mean, the prioritize we can
Nice.
with priority we can do. Let me just check the possibility. Okay.
Yes, ma'am. Thank you.
Yeah. Thank you. So see you all on Thursday. Thank you, everyone.
Thank you.
Yeah.
Thank you, ma'am.
Thank you.
Good night.
Thank you.
Ma'am.
Yes.